Hi everyone, so this is going to be the video over chapter 8. Just like for chapter 7, I'm going to do it in 2 parts, just for time constraints. And some of them will already have the work shown and typed out just so that it's a little bit easier to see. If you have questions, please email me so that I can help you understand any of the parts that you're confused on, and I hope you all have a good week. So the first one says when a manager fails to employ an economically efficient input combination, then the firm cannot be producing in a technically efficient manner. So economically efficient and technically efficient are not actually the same thing. There are technically efficient combinations that may not be economically efficient. Technically efficient just means that you are maximizing output, but you're not necessarily minimizing costs. So maybe you're producing the most that you can, but you're using the wrong mixture. You're using too much labor, you're using too much capital. However, economically efficient combinations will be technically efficient as well. If you are minimizing costs and maximizing, when you are minimizing costs, you are also maximizing output with those costs. So this question says a firm plans to produce 500 units per day of good Z. The firm's production engineer finds 2 technically efficient processes, input combinations to produce 500 units. If the production function for existing technology is Q equals a function of L and K, then this combination is coming from this, which means it will produce 500 units of output. And this combination is coming from this, and it will also produce 500 units of output. If the firm must pay $350 per day for a unit of labor and $1,500 per day for a unit of capital, which process is economically efficient? So which process will minimize your costs, alpha or beta? So we have $350 a day labor and $1,500 a day capital. So for alpha, we're going to have 350 times 625 plus 1,500 times 45, and that's going to give us 286, 250. And beta give us 250 times 350 plus 1,500 times 125. It's going to give us 275,000. So our lowest cost option out of those 2 options is beta. C says if labor falls to $300 per day and the price of capital remains $1,500 a day, which one is more efficient? Which one is economically efficient? So now it's $300 a day for labor and still $1,500 a day for capital. So alpha is going to be 300 times 625 plus 1,500 times 45, which is going to give us 255,000. Beta will be 300 times 250 plus 1,500 times 125, which will be 262,500. So when our price of labor changes and falls, then alpha becomes more economically efficient. Holding the price of capital constant, process alpha will never be economically efficient if. So we have to kind of set this up. So the way we're going to set this up is we're going to say that X is the price of labor to make it equal. So 625 times X plus 45 times 1,500 equals 250X plus 125 times 1,500, which is going to turn into 625X plus 67,500 equals 250X plus 187,500. And we're going to solve that. So we're going to have 375X equals $120,000, which means X equals $320. So if X equals 320, then alpha equals beta. If X is less than 320, then alpha is less than beta. X is greater than 320. Alpha is greater than beta. So process alpha will never be economically efficient if a unit of labor costs more than $320 a day. And that's what we see right here. Is more expensive. And then our less than 320, then alpha is less expensive than beta. Then the last part says the process that turns out to be economically efficient will depend on the prices of the firms that pay. The firms must pay for labor and capital. Economically efficient outcomes do depend on this because it requires firms to minimize cost. So economically efficient outcomes depend on these values. To minimize costs or maximize profit. And you see that I essentially have it just worked out here again with just essentially different colors. The next one says fill in the blanks for the following table. So our first one, our average product is 500. if we know that our average product is 500, that means that 500 divided by 1 was 500, which means our total product divided by 1 was 500, which means our total product is 500, and our marginal product is 500. If our marginal product is 700 on our second row, then that means that this is going to be 1200, because 500, wrote that in the wrong spot. This is going to be 1200. And we know that because 500 plus 700 gives us our 1200, which means our average product is going to be 600, because 1200 divided by 2 is 600. If our total product is 2000 for 3, then we know that our marginal product, which is the difference from here to here, is 800. So 2000 minus 1200 gave us our 800. And then our average product is going to be 2000 divided by 3, which is 666.67. If our average product is 625, then we are going to have, orange is the next color. We're going to have 625 times 4, which is 2500. And that's going to be our total product. And then from here to here gives us our marginal product of 500. So then our marginal product is 300. So we're going to add 300 to our 2500 and get 2800. So 2500 plus 300 is 2800. So then we have 2800 divided by 5, which is going to give us 560. So for our 6th unit of labor, we know that our total output is 2,970. So from here to here, we have that our output increased 170. So 2,970 minus 2,800 gave us our 170. And then we're going to divide that by 6, and we're going to get 495. For our 7th unit of labor, we know that our average is 415, so 415 times 7 will give us 2,905. From here to here, we see that we went down 65, so our marginal product is negative 65. And then our last one is negative 81, so we're going to have 2,905 minus 81, which is going to give us 2,824. Divide that by 8, and we get 353 as our average product. So average product is total product divided by labor. Marginal product is our change in total product. And then you see again that I have it written out with just a little bit more work in case you have any questions. The next one says, suppose your business is currently employing 750 workers. The only variable input at a wage rate of $48. The average product of labor is 96. The last worker added 6 units to total output, and the total fixed cost is $12,000. So what is marginal cost? Marginal cost is going to be how much we had to pay for that worker over the change in quantity. So 48 divided by 6 gives us $8. What is the average variable cost? This is our variable cost divided by our product of labor. So 48 divided by 96. So our wage divided by our average product of labor to get our 0.5. How much output is being produced? So we are going to multiply the average product of labor by our number of workers. So 96 times 750 gives us 72,000. What is our average total cost? Average total cost is average fixed variable cost plus average fixed costs. We already know our average variable cost is 0.5. So to find our average fixed cost, we're going to take our 12,000 that we're given in the problem, divide by our quantity that we're producing, 72,000, and we're going to add those two together. So 0.5 plus 0.167 gives us 0.667, or 2/3. Is average variable cost increasing, constant, or decreasing? What about average total costs? If our marginal is greater than our average, then our average is increasing. So since 8 is greater than 0.5, average variable cost is increasing. Since 8 is greater than 0.67, average total cost is increasing. That's the end of the first section. There will be another video for the multiple choice questions, just for time purposes. Hope you have a good week.